Chapter 3, Section 2 deals with quadratic equations, quadratic functions, zeros of quadratics, and models. Now we're going away from the easy stuff. We're building bigger. The next chapter, chapter 4, is there is no limit. It could be as big as it wants to be. But we have to start building our pieces up this way. So the first thing we have to look at is what is a quadratic equation? A quadratic equation is what is an equation? How do we know it's an equation? Exactly. It has an equal sign. So a quadratic equation looks like this. And we set it equal to 0. The only stipulation here is A cannot equal 0. Why is that an important stipulation? If A equals 0, what would happen? It wouldn't be quadratic. If that's 0, that's gone. It becomes a linear equation now. Y equals mx plus b. So we need to have A out there. This is what makes it quadratic. What is that number called? It's called the degree. A quadratic is a polynomial of degree 2. A quadratic function is the function name that defines this quadratic equation. Again, where A cannot equal 0, because if it did, then it wouldn't be quadratic anymore. Notice, this is important. A, B, and C are numbers. A, B, and C are real numbers. In other words, it could be any positive, any negative, any fraction, any decimal, it could be anything. Now, if it's written in this way, I'll put it down there. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. So whenever you solve quadratic equations, as with linear equations, it has to be equal to 0 first. Why does it have to be equal to 0? Anybody guess? Why do we have to set it equal to 0? Remember, this equation equals, this is the same as y. So when we put it in standard form, we're setting y equal to 0, which means we're looking for the x-intercepts, which is our solution. So that's the reason we set it equals 0. How do we find the x-intercept or the y-intercept? the y, remember back in chapter 1, the y-intercepts, you set x equals 0. In other words, the y-intercept is always the constant number. The degree of a quadratic equation is 2 because it's x squared. What is the x squared? What does the degree 2 tell us? What can we infer from if we see an equation with the exponent of 2? At most, 2 solutions. Two minus one vertices. Remember what a vertex is? A vertex? This is plural. Vertex is singular. What is a vertex? Anybody? A vertex, we have one of two possibilities. It's either the highest point or the lowest point. And quadratic equations, so we have 2 minus 1, we'll have one vertex. Because whatever your degree is, subtract by 1, and that's how many vertices you'll have. So far, so good? Now, what's going to be important here because our equation looks like this, if we can factor it, then it looks like something like this. And we're going to spend some time learning how to factor. So let's say this is an equation. We'll call that A, and we'll call this one B. These are equations inside there. There's a principle called the zero product principle that says this. If you have two numbers, A times B, and they equal 0, then what has to be true? If you have two numbers multiplied that equals 0, what has to be true? Either the first one is equal to 0, the second one equals 0, or they're both equal to 0. Do you know which one equals 0? No. So if that's the case, after we factor it, we take both of these factors and set them equal to 0, and then solve for x. Those are our solutions. Which are the factors, which are the x-intercepts. which are the roots. See, so the word solution has many synonymous meanings. It means solution means intercept. Factors, roots, zeros. All of these mean the same thing. Now, you see why they call them zeros? Because once we solve these, whatever the a equals, whatever the x equals there, if I plug it back in the original equation, it will equal 0. So that's why they're called zeros. And they also cross the x-axis. They're intercepts. They're factors because that's what I factor them out to be. So that's one of the things. Another thing, since we have a x squared, we have the square root property. Which says this. If x squared equals a number, any number, I don't care what it is. To solve for x, what do we have to do? We have to get rid of the square. How do we get rid of the square? Square root both sides. But remember, the root, the exponent tells us our number of solutions. So whenever you take the square root of x squared, you have to put a plus and a minus in front of the answer. Let's see why. For example, if x squared equals 4, and I square root both sides, the square and the square root cancel, so I have x equals plus or minus. What's the square root of 4? 2. Now, what I'm saying here is, in my original equation, x can be either positive 2 squared, or it could be negative 2 squared, and they both equal 4. So that's like whenever you take a square root of x squared, you have to have a plus or minus in front of the answer. So look at the examples. Example 1. Let's hold off on those because they're jumping in without giving you any preface. Again, it's not giving you the chapter itself doesn't give you enough information. Now, we know that ax squared plus bx plus c equals 0 has at most 2 answers or solutions. Why is that? If it's at most 2 solutions, what are the other possibilities? What is the graph of the x squared? That's square root of x. Anybody? What's the graph of x squared? It's an even power, so that means it's symmetrical about the y-axis. That's the x squared. Thanks for memorizing those, everybody. So at most, we can have two solutions. There. What does that mean? Our graph can look like this. We can have two solutions. Or the graph can have only one solution. Or the graph can have what we call no real solutions. Here, you're going to have imaginary solutions. So far, so good. And later on today, if we have time, I'll show you how you can determine how many solutions you'll have at the very end. So let's look at this. Hopefully by now, I'm going to give you 4 pairs of numbers. X plus 2 times x plus 3. X plus 2 times x minus 3. X minus 2, x plus 3. X minus 2, x minus 3. Multiply those numbers together. Each pair of these. Remember how to do that? So go ahead and do that. FOIL those. Positive and positive. 2x positive, negative, 2 times 3. Combine like terms. 3 is bigger. 3 minus 2 is 1. Positive, negative and positive, negative and positive. 3 is bigger, it's plus. 3 minus 2 is 1. Positive times negative is negative. Negative times positive is negative. Negative and negative is a positive. They're both negatives, so there. This is what you should have gotten. So that's the multiplication part. That's the easy part. Now we have to go backwards. I'm going to give you equations like these. You have to tell me what they break down into. And it's easier than you think. Trust me. So for example, I'm going to do an example here. Well, I'll write down. And here are the steps. We want to factor quadratic equations. Let's look at the first one. We have x squared plus 5x plus 6. Put two parentheses down. And remember, it's ax squared plus bx plus c. Put ax in the first part of both parentheses. So what is my a in the first one? What's a? 1. A, B, and C are numbers. There are no x's in A, B, and C, only numbers. So I put x and x here, 1x and 1x. Third step. Look at the second sign. Look at the second sign. That's that one. If it is a plus, then both signs in the parentheses are the same. They are the first sign. If the second sign is a plus, then both signs in the parentheses are going to be the same thing. So in this one, since the second sign is a plus, it's going to be, both of these are going to be pluses because the first sign's a plus. Now B, if it is a negative sign, if the second sign is a negative, the signs are opposite. In other words, one gets a plus and one gets a minus. And the larger number that we're going to find next will get the first sign. So if the second sign is a minus, that means the signs are opposites. One's a plus, one's a minus. And when we find the numbers, the bigger number gets the first sign. Now step 4. Multiply A times C. So what that means is multiply the first number times the last number. So 1 times 6 equals 6. Find what two numbers multiply to equal, let's call this D, to equal that D, whatever that A times C is. That when you second sign them, you get B. So what does that mean? So we did A times C. We got 6. This is our D. What two numbers multiply to equal 6? That when, since the second sign is a plus, that when we add them, we get that middle number, 5. This is the B term. This is D. So what two numbers multiply to give you 6? When you add them, you get, yep. Yeah, 3 times 2 or 2 times 3. Since both signs are the same, it doesn't matter which ones you put in there. There's a factor.
So if it was negative.
Well, we'll get that. We'll get to there. And sure enough, our answer x plus 2, x plus 3 is what it's supposed to be. Does it matter which order I put them? By the commutative property of multiplication. Doesn't matter. Okay, let's look at the next one. The next one was x squared minus x minus 6. So since we're going to factor those, I put the parentheses out there. According to the procedures, what do I do first? Whatever this first number is here goes in the first spaces. Then I look at the second sign. It's a minus. What happens? What does that mean? If the second sign's a minus, then they're opposite signs. Okay, so back then, now we multiply A times C. So A is 1. 1 times 6 equals 6. That's my D. So what times what equals 6? And that's a minus sign. That when I subtract them, it equals 1, which is my B term. So what times what equals 6? When you subtract them, you get 1. 3 times 2, 3 minus 2. But let's look at this rule again here. It says if the second sign's a minus, opposite signs, and the larger number gets the first sign. So 3 is larger, it gets the minus. So 3 goes there and 2 goes there. And there's our factor. X squared plus x minus 6. So I take whatever's in front, I put it in the first spaces. The second sign's a minus, which means one's plus, one's minus. And the bigger number will get the plus. So A times C, which is 1 times 6 equals 6. What times what equals 6? When I subtract them, I get 1. Again, 3 times 2, 3 minus 2. But this time, the bigger number gets the plus. Because the first sign is a plus, the bigger number gets the plus. And the last one, finish that one. The same steps. What goes first? X and X. What signs go in there? Yes, both signs are the same. They're both negative. One times 6 is 6. But when I add them, I get 5. And they're both negative, so it doesn't matter. Because the second sign's plus. If the second sign's a plus, then they're both the same sign. It's whatever the first sign is. Because if they were both plus, there's no way we get a minus here. So that's what that second sign means. This method works no matter what. Because so far, we've only talked about our leading coefficient being 1. It could be anything now. So let me go ahead and put one together. Put it together real quick. So, okay, everybody ready? So here's the next one. 6x squared plus x minus 12. There's only one small change at the very end. We'll talk about that when you get that far. Okay, that's good. So whatever is in front, that goes in both of these. Again, follow the procedures I gave you. Don't deviate with what you think. I mean, you can if you want to, but the second sign's a minus. What does that tell us? The signs are different. One's plus, one's minus. The bigger number will get a plus. Now comes the hardest part. 6 takes A times C, which is 6 times 12, which is 72. What times what equals 72 that when we subtract them, it equals 1. 9 times 8, 9 minus 8. Because the sign's not relevant because we're going to arrange them as we need to. So it's just the numbers. So we have, and then since the first sign's plus, 9 goes with the plus and 8 goes with the second one, with the minus. We're not done yet. Now, this is as far as we got last time. But you notice how the first number is too big. So the only difference here is what can you factor out of both of these? What can you factor out of the first one? They both have a 3 in common. Now, when you factor something out to see what's remaining, divide both of these by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. How about the second one? What do they have in common? A 2. So I divide both of these by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Whatever you factored out, get rid of it. Delete, erase. This is our final answer, our final factored form. Because the first two numbers multiply to give you 6x squared. The last two numbers gives you negative 12. Then we check the middle also. 2 times 4 is 8. 3 times 3 is 9. 9 minus 8. So this is the most easiest way you can do factoring. So now we're going to look at solving equations. Time's running by. It's almost done already. So. If you have a binomial equation. What does binomial mean? Two terms. In other words, if you have something that looks like this, 2x, oh, we're doing squares, square minus 8 equals 0. If you only have one term, if only one term has an x, then move the constant term to the other side. So add 8 to both sides. Divide by 2. And then use the square root method. So x is equal to plus or minus 2. So if you have a binomial and only one term has an x, or only variable you have there is x squared. The other term possibility is 2x squared minus 8x equals 0. If both terms have an x. If both terms have an x, then you factor. What do both of these have in common? What number do they both have in common? They both have a 2. Anything else in common? What's that? 8? No. This one doesn't have an 8. They both have a 2 in common. Anything else they have in common? They have at least one x in common. So we divide both of these numbers by 2x. X squared divided by x is simply x minus 8 divided by 2 is 4. So if you have both terms of x's, factor them out, you'll have two separate terms. Set both of these equal to 0. And then solve for x. So x is equal to 0. And x is equal to 4. Those are my two answers. Unfortunately, we're out of time. I know that you guys will have a hard time not seeing me until Monday. We have class.